I think today a lot has been spoken about designing fault-tolerant applications and security. So I'm going to concentrate more on auto-scaling. It's about the scalability feature of Amazon. This is one of the most important pillars of Amazon Web Services. So we'll dive deep into it. So what I've done is I've put together some of our experiences on dealing with Amazon auto-scaling in our customer cases, and I've put together this presentation. So these are some of the load patterns what we observe in the online business. So if you see e-commerce, they have weekly variations of their traffic, spikes and valleys every day, and on the right, if you see, like, there is online ticketing. Typically, if you take PVR, Siriconas or Inox, a lot of their booking happens between Wednesday till Sunday, and their traffic mainly happens during those periods, and their server utilization, their hardware utilization, as well as their load traffic pattern is kind of skewed. Next, you look at online travel. Yearly, if you see, an online travel industry has got seasonal loads. During the peak seasons alone, they have a lot of variations in their load and traffic and their server utilizations. And then if you have any campaigns or tests done, that time alone, we see there is a lot of loads. There are two kind of burst types, load burst types, typically that we observe. One is unpredictable bursts, which doesn't have any pattern, which has spikes and valleys. And then there is the predictable burst, which happens during a specific time or a specific period in a day or a time period. So typically, if you see, traditionally what companies used to do in online businesses, is like they used to plan their capacity, and given the variance in the load scenarios, it becomes quite complex to plan the capacity. And either what happens is there will be underutilization of resources or overcapacity planned. That's part of the wasted capacity. And certain times what happens is they under-provision the capacity itself, and when the load peaks out, there are a lot of lost customers. So is there a way where we can have our hardware capacity aligned with our load traffic and hence avoid such lost customers as well as save costs? The answer for this problem is typically Amazon auto-scaling. So what is Amazon auto-scaling? Amazon auto-scaling is one of the services offered by Amazon, which can handle wide variety of load bursts and wide variety of burst type patterns. You can scale out Amazon EC2 instances seamlessly and automatically when your load increases. You can scale down your unwanted Amazon EC2 instances when your load subsides. So typically, if you take in a day between morning 9 to evening 9 o'clock, if you have a lot of loads, you can be running 10 to 15 servers. And from night 9 to morning 9 again, when you do not have the peak, when it is just the load subsides, your servers can come down to a normal state. So this is possible through one of the services of Amazon. So now let's get into the Amazon auto-scaling architecture and some of the key concepts in auto-scaling. So Amazon auto-scaling primarily works on CloudWatch. CloudWatch is the monitoring service of Amazon. CloudWatch, what it does is it monitors the server farms that we run on Amazon Web Services, and it keeps feeding the details, the metrics and the data into the Amazon auto-scaling system. So on the Amazon auto-scaling system, what we can do is we can set up triggers, policies, to handle such changes on the load patterns. So what we essentially do is we set up something called as a launch configuration. A launch configuration is something where we mention the AMIs, the web server AMIs, which has to be launched. And then we go and create something called as an auto-scaling group. The auto-scaling group would have what availability zones these servers has to be launched, the web servers, whenever there is a load spike. What is the minimum number of servers that has to be run? What is the maximum number of servers that could be run whenever there is a spike? And all these things are set up in the configuration group. And then a trigger. A trigger consists of two components. One is policy and then an alarm. Alarm is something that's being fed from the CloudWatch. We can set up an alarm in CloudWatch saying that whenever the CPU goes above 80%, then trigger an alarm and send it to AutoScaling. Or whenever a CPU goes below 20%, trigger a scale down alarm and send it. So we can set up a policy inside AutoScaling of Amazon saying that whenever you receive an alarm to scale up instances, trigger this scale up policy, whereby you can add more EC2 instances into your server farm dynamically and automatically. And whenever your CPU utilization goes below 20% and it stays there for like few minutes, and you can have a scale down policy set on your AutoScaling, which can be inputted from the CloudWatch, and it automatically brings your server down. And on the right, if you see, AutoScaling groups contains EC2 instances, and all these EC2 instances can be seamlessly attached to Elastic Load Balancer. So that is one of the important benefits of having AutoScaling. So this, what it means is, if you have your web layer, your web tier, and whenever the traffic increases, your web tier can be triggered by the CloudWatch, and the AutoScaling can create new EC2 instances on your web tier depending upon the load, and they can be automatically attached to your load balancers. So your load balancer starts dynamically transferring the traffic to your EC2 instances, which are your web tiers, and thereby handling massive load. Typically, like Elastic Load Balancers can take, some of the tests that has been done can take 20,000 requests per second. So that's huge. And for that, AutoScaling, if we have enough servers set on the back, your sites can elastically scale and come down depending upon the need. So we saw two types of burst types. So let's see how can we address both the burst types using Amazon AutoScaling. So the first burst type is unpredictable burst, where we do not know like what's going to be the spike and valley in a day. So for that, how do we use AutoScaling and address that scenario? So typically what we can do is we can have an on-demand AutoScaling policy set. In an on-demand AutoScaling policy, you can say like the minimum number of instances that I should run, EC2 instances that I should run when my load is low is 4, and the maximum number of EC2 instances that I can run when my load peaks out can be 24. I can make both these EC2 instances, I can make the EC2 instances spread across and run in multiple availability zones of Amazon that internally offers a lot of high availability and fault tolerance. And I can seamlessly attach it to the load balancer. And I can also mention the cooldown period. Cooldown period is something like where we do not want our servers to be scaled rapidly up or brought down rapidly down. So you can set up enough cooldown period so that your scaling happens at a specified intervals. So for predictable burst, there is an option where we can schedule a specific time. We can configure in Amazon AutoScaling saying that between morning 9 to 11 o'clock alone run 50 servers, and then bring the entire load down after 11. Then evening between 4 o'clock to 6 o'clock alone run another 50 servers. So taking this input, the whole infrastructure can act very dynamic. So depending upon the specified time interval, your infrastructure can elastically go up, serve the requests, and come down automatically. As well as in the evening, again it can go up and come down. So such complex automations are possible using Amazon AutoScaling. And you can configure AutoScaling in just simple 4 steps. Unless you understand like all the fundamentals and the intricacies behind it, it's just simple 4 steps to configure and to use it. So what are the candidates for AutoScaling? Not all the tiers are candidates for AutoScaling. Like web tier, as I explained, is a typical candidate for AutoScaling because your web tier should expand and come down depending upon your load traffic. Your application tiers are very good candidates for AutoScaling, like where you can have your Tomcat servers scaling, which contains your application logic, scale out and scale down depending upon your load traffic needs. Your caching tier is also a candidate. And load balancing tier, either if you are customizing a load balancer or if you are using Amazon's Elastic Load Balancer, depending upon that you can have AutoScaling. And even if you have other stateless tiers in your application architecture, those are potential candidates for Amazon AutoScaling. Databases are not candidates for Amazon AutoScaling. You cannot have Amazon AutoScaling configured to make your database tiers dynamically go up and down. They are not candidates. So these are some of the cost savings. This is some of the benefits that we have observed after architecting AutoScaling to some of the customers. Typically, if you see e-commerce customer who has implemented AutoScaling into his architecture, saves nearly 35%. It varies between whatever percentage, but it depends upon the server farm size. And a person having online business having a pattern of like an online ticketing or something can save around 30%, and seasonal loads can save around 35%. Another important benefit of AutoScaling is it closely aligns your infrastructure with your load traffic needs. Since it closely aligns your infrastructure with your load traffic needs, it saves a lot of cost. And for the IT operations, it is really good because they need not worry about under provisioning of their infrastructure, and when the peak happens, the servers crash, or they need not worry about over provisioning of their infrastructure and wasting money. So they can keep their entire infrastructure aligned with the needs, the load requirements, and thereby saving costs to the company as well as having peace of mind. So let's get into some of the key points that we have to remember when we are doing AutoScaling. So AutoScaling, typically what happens is it starts creating a lot of machines, a lot of EC2 instances dynamically. And when your scale down trigger occurs, it brings down your boxes, your EC2 instances down dynamically. So in such cases, we have to take care of our log files, data files, and sessions. Because typically if you have your web or your application tier, you might have a lot of log files, data files, user uploaded files, sessions and all created. So the best way to do this is move all these information to a centralized location. The centralized location could be for your files. S3 is one of the best locations of keeping your data files and log files, periodically moving it from your EC2 instances. Sessions, try to keep it in your Elasticache or keep it in your database depending upon the app. As much as possible, like make the server that are there in the AutoScaling layer stateless. That's the idea. AutoScaling currently runs on multiple AZs inside a region. So Amazon has got 6 regions around the world, and every region has got in the scale of like 3 to 4 or 2 to 3 AZs. So AutoScaling seamlessly works within a region across multiple AZs. So you can give input to AutoScaling and make it spawn servers, EC2 instances across multiple availability zones. So in a sense, by implementing AutoScaling, you get a lot of high availability benefits as well, because your web servers, your app servers are getting launched in multiple availability zones, and each and every availability zone is a distinct data center. They are connected by low latency network. They have their own power, their own cooling and everything. So it offers a lot of high availability, and doing this is just a configuration. There is no change needed in your app. It's just a configuration thing that you have to do. If your app is perfectly distributable, it can be run in multiple boxes or multiple pieces, then you can easily leverage a multiple AZ feature and AutoScaling combined to have high availability as well as scalability achieved. We have observed that EBS-backed AMIs, EBS is Elastic Block Storage, which is one of the services of Amazon. We have observed that EBS-backed AMIs are faster to launch in AutoScaling mode. So typically you can have your new instances launched within 30 seconds in EBS-backed. And one of the best practices is when you combine AutoScaling for launching your boxes, as Janakiram pointed out, make sure all your configurations and user data files are kept in a different location, and they are downloaded dynamically when your EC2 instances are launched. So it's typically like just assume there are a lot of the application tiers are getting launched depending upon the load. You do not want to have a configuration fixed in the application tier. So what you do is make all the configurations lie in a centralized repository, download them whenever the boxes come up. So this is one of the deployment best practices, what generally we recommend when using AutoScale. You can also use like other tools like Puppet or Chef in combination with AutoScale to achieve this. Currently, you can have only one instance type attached to an AutoScaling group. What does it mean is like you cannot scale web tier or application tier in different instance types. Like if there is an M1.large, which is a 2-core 7 GB RAM, you can increment your web tier on installments of M1.large. You cannot combine M1.large and an extra large into a same AutoScaling group. So why this point is very essential is when we are doing a capacity planning, when you are using Amazon, you need not to do a very detailed capacity planning, but you need to know which is the base capacity or the installment capacity on which you have to AutoScale. If that is not sized properly, again there will be some leakages that's there in the cost. So make sure the installment capacity on which you are going to do AutoScaling is a good capacity for you. The another point is combining custom CloudWatch metrics. This is a very good feature. CloudWatch offers something called as custom parameters. Currently, CloudWatch sends CPU utilization and network metrics for the AutoScaling to happen. Whereas we can combine custom CloudWatch metrics, whereby you can have your Tomcat threads, requests, and memory sent to AutoScaling, and you can have AutoScaling read these parameters through CloudWatch and accordingly scale. So instead of just the CPU, you can scale based on the number of threads, or you can scale based on the sessions. You can scale based on the memory of your Tomcat. So this is one of the important features, because not all the times CPU alone might be the factor based on which you will have to do the scaling. So when you have to do scaling based on some custom parameters, you can leverage the custom CloudWatch metrics of Amazon, combine it with AutoScaling, and do the scaling part. The final point is evaluate traditional monitoring, because when you do scaling, there will be suddenly 50 boxes, 10 boxes, and things are going up and down. If that is the case, traditional monitoring tools, which typically works on the model of agents residing on the web boxes or the app boxes, and the server talking to the agent first, registering, and then working, this model might not work, because your servers, the EC2 instances, suddenly there are 50 instances and 10 instances. Sometimes your traditional monitoring tools might detect that the servers are not running, and it starts sending false alarms. So what we suggest is, like, when you are evaluating and choosing a monitoring tool in combination with AutoScaling, make sure that it understands that these servers are working in AutoScaling mode and they do not send false alarms and noises. So to summarize, in short, AutoScaling aligns your IT with your load and traffic needs. It can help you to scale down your scale up, scale out your infrastructure, and scale down your infrastructure according to your load traffic patterns. It can work on various types of load patterns and burst types. It can solve a lot of infrastructure and IT problems, and then thereby solving your online business problems as well. So that's it.